I'm Shalika from Department of Computer Applications. Today I am going to discuss a very important topic of theory of automata in formal languages, and name of topic is Chomsky Hierarchy. The content which I am going to cover in this topic is, first of all, I will discuss Chomsky hierarchy concept. After that, type 0 grammar, and type 0 grammar is known as the unrestricted grammar. After that, we will discuss type 1 grammar. Type 1 grammar is known as the context sensitive grammar. After that, we studied the concept of type 2 grammar. Type 2 grammar is known as the context free grammar. And at last, we will study the type 3 grammar, and type 3 grammar is known as the regular grammar. First of all, we studied the concept of Chomsky hierarchy. Chomsky hierarchy is basically described by a scientist named as Noam Chomsky, and this hierarchy is described in 1956. Chomsky hierarchy basically represents the class of the languages that are accepted by the different machines. According to Chomsky hierarchy, the grammar which are studied till now in theory of computations are divided into 4 types. First one is type 0 grammar, which is known as the unrestricted grammar. That means there is no restrictions on this grammar. Next type of grammar is known as the context sensitive grammar, which comes under the category of type 1. Next grammar is type 2 grammar, which is also known as the context free grammar. And at last, the concept of regular grammar is there, and the regular grammar is known as the type 3 grammar. So this is the hierarchy of the Chomsky. In this grammar, the regular grammar is the subset of all the grammars, and the unrestricted grammar is the superset of all the grammars. That means every language which is of type 3 is also of type 2, type 1 and type 0. Similarly, every language which is of type 2 is also of type 1 and type 2 and etc. So let's study the concept of all these grammars one by one. First of all, we will discuss the type 0 grammar. Type 0 grammar, as its name indicates, it's an unrestricted grammar. That means there is no such restrictions on this type of grammar. This grammar is a grammar which is recognized by the Turing machine. And the language which is recognized by type 0 grammar is known as the recursively enumerable language. In type 0 grammar, the production is basically of this form. It means alpha tends to beta. There are some rules for the alpha as well as for beta. That means alpha is basically a combination of non-terminals and the terminals. We already know the concept of non-terminals and terminals. Non-terminals are always written in capital letters, and terminals are always written in small letters. So let's see the this syntax of the alpha. Here B represents the non-terminal, or we can also say that the B is a variable and T is a terminum. So alpha is a combination of terminals as well as non-terminals, but there must be at least one variable on the left side of the production. That means alpha always contains at least one variable or non-terminal. So beta, the rule for the beta is that beta is the combination of variables as well as terminals. But the point to be remember is that there is always a one variable on the left side of the production, left hand side of the grammar. So let's say the example of this. Let's take this here. SAB tends to BA. Here S, as it's written in a capital letter, so it is a non-terminal, and the symbols that are written in small letters, these symbols are the terminals. Here A tends to A, that means A is a non-terminal and B is a terminal. So the variables that are written in capital letters, these are the symbols that are written in the capital letters are known as the non-terminals, or they are also known as variable, and the symbols that are written in small letters are known as the terminals. Next grammar is type 1 grammar, and type 1 grammar is known as the context sensitive grammar, and the language that can be recognized by the context sensitive grammar is the CSL. CSL stands for the context sensitive language, and this language is recognized by the linear bounded automata. So we have to remember these things very much. These are the very important points, that the language that is generated by the type 0 grammar is recognized by the Turing machine, and the language generated by the type 1 grammar is recognized by the linear bounded automata. As we studied in a type 0 grammar, that means there are some rules of the production. Same in type 1 grammar, there are some rules of the production. Here again, the production is of two types. The production is of this form: alpha tends to beta. As we already know that grammar is basically a set of four tuples. In grammar we have four tuples, as we already studied in previous videos, that grammar is the combination of grammar is a set of four tuples. Here V is a set of non-terminals, T is a set of terminals, P is the production rule, and S is the start symbol. So in type 1 grammar, the production rule is of this form: alpha tends to beta. And we have to remember one thing, that the symbols of alpha, symbol of alpha is always less than or equal to the symbol of beta. That means the length of alpha is always less than or equal to the length of the beta. So let's take an example. This type of production rules is in the form of type 1 grammar. Here we see that here the length of the alpha is 1 and here the length of the beta is 2, as there are two non-terminals. Here the length of alpha is 2, so here the length of the beta is 3. Here the length of alpha is 1 and length of beta is 1. So as we see in this example, that the length of alpha, or you can say that the symbols of alpha, count of symbols in alpha is less than or equal to the count of symbols in beta. So again, as I already told, that the symbols that are written in capital letters are known as the non-terminals, or they can also known as the variables, and the symbols that are written in small letters are known as the terminals. Type 0 grammar is known as the context-free grammar, and the context-free grammar and the language generated by the context-free grammar is known as the context-free language, and the language generated by this grammar is recognized by the push-down automata. Push-down automata is basically an automata that's the combination of finite automata plus stack. As we know that there are very limited memory of finite automata. That means finite automata is not able to recognize the strings, or it has very limited memory. So for removing the drawback of finite automata, we use the concept of the push-down automata, and push-down automata is taking the help of stack for recognizing the strings. So here we use the concept of stacks, and there are two operations: push operation and pop operation, that we already studied. And it may be possible that we didn't perform any operation. Right? Again, there are some rules for writing the type 2 grammar, and the rule of this is that, as I already told, that the type 2 grammar must be in the form of type 1, and left side of the production can have only one variable or only one terminal. As we seen in the previous videos, that in context sensitive grammar, the left side of the production has two variables. Fine, but it is necessary that if we are talking about type 2 grammar, then there must be only one variable on the left side of the production. So let's take an example. The left side of the production always contains only a single variable. But what about the beta? As this production is of this form, alpha tends to beta, alpha must be contains only single one non-terminal, but there is no restriction on beta. We have no restriction on beta, but we have to take care of the alpha symbol, and alpha always contains only one variables. So the length of alpha, or you can say that the count of symbols on the left side of the production is always equal to 1. Here S, A and B that are written in capital letters are known as the non-terminals, or they are known as the variables, whereas the symbols written in small letters are known as the terminals. Last grammar is type 3 grammar. Type 3 grammar is also known as the regular grammar, and regular grammar is very restricted grammar. This one is very restricted grammar, and the language generated by the regular grammar is known as the regular language, and the language generated by the grammar is recognized by the finite automata. As we already studied in previous video, that in finite automata we have two types of automata. First one is the NFA and second one is the DFA. Non-deterministic finite automata and deterministic finite automata. So there are so many rules on these type of grammar. So type 3 grammar is the most restricted form of grammar. This grammar is always given in the form of this. Here the left side contains a single non-terminal, and on right side maybe it's in this format or maybe in this form. Here if we see that here's the symbol V, non-terminal V, and here again the non-terminal is on the left side. Left side of the grammar. So if the non-terminal is on the left side of the grammar, then the grammar is known as the left regular grammar. Where here the V, this symbol is on the right side of the grammar. So this grammar is known as the right regular grammar. So let's take an example. As we see that here S is the start symbol. S tends to capital A, small a. Here capital A is the non-terminal and small a is the terminal. Fine. Here the non-terminals comes on the left side of the production. So this one is an example of left regular grammar. But in case if the production rule is written in this format, so here the non-terminals comes on the right hand side of the production, right hand side of the terminal. So this production rule is known as right regular grammar. Right regular grammar. So as we see whether the non-terminals comes on the left hand side of the terminal, or it may be possible that non-terminals comes on the right side of the right hand side of the terminal. So if non-terminals comes in the left side, then it's a left regular grammar, and if it's non-terminals comes on the right hand side of the terminal, then it is known as a right regular grammar. So that's all about the Chomsky hierarchy, and it's a very important topic of theory of automata and formal languages. So we have to remember some points that the type 3 grammar is the regular grammar, and the language generated by the regular grammar is regular language, and the automata that is recognized by the automata which recognize the regular grammar or regular language is known as a finite state automata. If I am talking about type 2 grammar, then the type 2 grammar is known as the context free grammar. The language generated by the CFG, it is a CFG. The language generated by the context-free grammar is known as the context-free language, and the grammar is recognized by the automata, and the name of the automata is push-down automata. If I am talking about type 1 grammar, then type 1 grammar is known as the context-sensitive grammar. Language generated by the context-sensitive grammar is context-sensitive language, and the automata that can recognize this grammar or this language is known as the linear bounded automata, and there are some conditions for writing the production rule of this grammar. And type 0 grammar. Type 0 grammar is the unrestricted grammar. That means there is no such restrictions on this grammar as we seen in other grammars. Type 1 grammar or type 2 or type 3 grammar, there are some restrictions on the alpha or beta. But type 0 grammar is the unrestricted grammar. There is no restrictions on any production rule, and unrestricted grammar generates a language, and the language is known as a recursively enumerable language, and the automata which recognize this language is known as the Turing machine. So I hope you are able to understand this concept very well. So thank you.